Welcome to my channel. Let us discuss two important questions on electrostatics. The physical concept is very important for Jee-Main-Advance examination as well as Neet. Now the question is, first question, two square metallic plates of side L are kept D apart in air. One of the edges is perpendicular to oil surface in a tank filled with insulating oil of dielectric constant K. The plates are connected to a battery of EMF. The plates are then lowered vertically at a speed V. Find the current drawn from the battery in the process. Now, let us try the solution. This is the tank and the parallel plates, conducting plates are here separated by a distance D. Now this is oil. Oil has dielectric constant K. Now the length of each side is L. This is L. Now at the time t equals 0, when the plates were all in air, it just touches the surface of the oil. Now at that moment, the capacitance we can find out, that is epsilon 0 area of either plate by separation D. Now the moment the plates of the capacitor as a whole is dipped or moves at a velocity, the plates moves at a velocity v. Now the capacitance will be different. A part of the capacitance, a part of the plates in air will form one capacitor, and the part remaining interior of the oil will form another capacitor, and the combination will be a parallel combination. Since the capacitance will be changing, the charge will be changing, and we can find out the current. Now see, let V with the speed it is given. In a time t, the plate has entered a length equal to, this length is Vt. So the portion that is above the oil is L minus Vt. Now the capacitance of the capacitor constituting the plates, parallel plates above the surface of the oil is equal to C1, say epsilon 0 permittivity of air. Area is equal to length into L minus Vd. L minus Vt. This is epsilon 0 A divided by separation between the plates is D. Now the portion of the parallel plates inside the oil constitute one capacitance equal to permittivity of the oil medium, that is dielectric constant, multiplied by the permittivity of free space or air, epsilon that is, and the area of the either plate, that is equal, this is Vt and this length is L, that is L into Vt by separation D. Now C1 epsilon 0 L minus Vt by D, C2 K epsilon 0 L Vt into D. A source of EMF or battery of EMF is connected to the plates. Now the total capacitance is since it is in parallel combination, C equal to C1 plus C2, that is epsilon 0 L minus Vt by D plus K epsilon 0 LVT by D, or epsilon 0 L by D taking common. Epsilon 0 L by D, we have L minus VT. Epsilon 0 L by D is K VT. Let us now, this is the total capacity of the plates, which is a function of time. Now, as you know, C equal to charge by potential difference. So, charge at any instant on the plates of capacitor is Q as a function of time equals C into V, that is epsilon 0 L by D, L minus Dt plus K Dt. This is C into V. In place of V, it is given the EMF is equal to E. So let us write EMF of the cell equal to the potential difference under the assumption that the cell has no internal resistance. So let us write E is a constant. Now, charge is expressed as a function of time. So the current is equal to I dq by dt, epsilon 0 L by D. L is constant, so derivative 0, minus V plus K into V, EMF E, or this is epsilon 0 L by D, K minus 1 speed into EMF E. So the current drawn from the battery is equal to K minus 1 speed EMF of the cell L by D into epsilon 0. Now this, you know, whether a derivation or expression is correct or incorrect, you can check with the boundary conditions that if there is no oil, then once the capacitor is completely charged, there is no variation of the capacitance when it moves downward or upward, and the charge is in steady state, the current drawn is 0. That is, if K equal to 1, the current should be 0. If you put K equal to 1, the current is 0. So this is the correct expression for current for this situation. Now, this is a conceptual question, very important for analyzing other questions. Second question is, a point charge plus Q is at a distance d from a conducting plane. A point charge plus Q is at a distance d from a conducting plane and is transferred to infinity. Find the work done in the process. This is like this. Say I am drawing a line for the conducting plane and a charge plus Q is here. Assume that this is the x direction or x-axis. Now, this is a conducting plane. We know that in case of a conducting plane and a charge, there is a force of attraction existing between the conducting plate and the charge. And how to find out an expression for that, and how to find out the amount of work done in the process by transferring the charge to infinity. Now, the lines of force from the positive charge emanating will meet the surface of conductor perpendicularly. Line of force meeting the surface of conductor perpendicularly. And this problem is solved on the basis of concept of image charge, that is, this plus q charge produces an image on the conducting surface as an object forms an image in a plane mirror at equidistance from the conducting surface. That is, if this distance is d, then this distance is d, and this is a minus charge minus q. So that the lines of force emanating from positive charge will converge to negative charge. Now, one should consider the image charge plus q, image minus q at equal distance. Now, remove, take away the conducting surface, and very important condition is that the surface of this conductor is equipotential surface. As there is no charge, the potential is zero, the potential of the surface is zero, and these two charges should satisfy that at every point on the surface of conductor in here, the potential should be zero. That is, since each point is equidistant from the two charges, the potential is zero. That is the main condition. Now, remove, mentally take away the conducting surface, the conducting plane. Now, the force between them you can find out using Coulomb's law of force. Now, in our question, it is given that you have to find out the work required to transfer the charge plus q from the point, that is distance d, to infinity. This is a problem involving a variable force, and which you can solve using differential integral concept, and that is, you find out an elemental work, then integrate within a particular limit to find out the work. Now, let us choose the charge plus q to be at a distance x at any instant of time. The force acting on the charge plus q is equal to 1 by 4 pi epsilon 0 q square. Distance x, image charge, is also at the same distance, minus q, this is x, so 2x whole square. Magnitude and direction is along negative x-axis, so minus I cap. And let this charge plus q be given an elemental displacement dx along positive x-axis. So dx vector is equal to dx plus I cap. As a result, the elemental work done in transferring the charge plus q through a displacement dx is equal to dw. Now this is f dot dx. So I cap dot I cap 1. So plus minus. So I can write this is equal to 1 by 4 pi epsilon 0 q square by 4x square into dx with a negative sign, because we are considering electrostatic force. If you consider the force exerted by the agent, then it will be plus. The agent must apply a force opposite to the direction of the electric force, so that to transfer the charge. Now, the work done equal to integral dw 0 to w minus 1 by 4 pi epsilon 0 q square into 1 by 4 integral x to the power minus 2 dx, x varying from d to infinity. Now, integrating is equal to minus q square 16 pi epsilon 0 x to the power minus 2 plus 1. After integration, this is minus 1 by minus 1. So this minus 1, this minus is positive. So it is infinite upper limit, lower limit d. As a result, the work done equal to q square divided by 16 pi epsilon 0 1 by infinity minus 1 by d, or this is equal to work equal to minus 1 by 16 pi epsilon 0 q square by d. So work is minus 1 by 16 pi epsilon 0 q square by d. Negative sign is due to the electrostatic force of attraction. Now, it is a very conceptual problem involving a conductor and the charge. You can solve this problem easily by considering image of the charge. This is a plane surface given, but you can consider the different curved surface. Suppose it's a curved conductor and there is a charge here plus q. Similarly, image charge will be formed somewhere here if the radius of the conductor curved surface is capital R and this distance is d. See, it's very important but easy. You can use the concept that the potential 0. This is charge minus q. Imagine the image charge here. You can find out the potential due to these two charge distribution and set it to be 0, and that will solve the problem, find out the distance. Now, this is how you can solve problems in electrostatics by the method of image charges. I hope this discussion will benefit the students appearing IIT entrance examination and also Neet examination. Thank you.